Hi all, now we are going to see about a video on case study in the subject called design and analysis of algorithm. Let's proceed. For the algorithm analysis, this case study is meant to demonstrate the salient features of algorithm design and analysis as discussed. A simple example is used here to systematically describe the following step. The steps are problem statement, algorithm design, implementation using pseudocode, analysis of best, worst, and average running times, space complexity, correctness of algorithm, and visualization of the analysis. First, let me see about the problem statement. The problem statement here I have taken is about the design and algorithm to find maximum element in an array of size n. Next, I have to analyze the algorithm to determine the time efficiency, space efficiency, and its correctness. So here we are going to see about the algorithm design. The design features are expressed in plain language. The algorithm for the solution of the problem consists of the following step. Step 1, store the first array element in variable max. Step 2, scan array to compare max with the array elements. Step 3, replace max with a larger element when found during the scan. Step 4, return value held by max. So next is algorithm analysis. We are going to write the pseudocode for the algorithm. The procedure find max returns maximum element in an array. The array A and its size n are passed as arguments. The following pseudocode describes the essential steps together with comments which are identified by the symbol. So the first line is max tends to a of 1, storing the first array element into the variable max. For j ranges from 2 to n, do scan remaining elements. So if a of j is greater than max, and here I'm going to compare an element with the max, then max is assigned with the value of aj. Now I'm going to replace the max value with a larger element. Next I'm going to return the maximum element. So this is the cost of the basic operation. So first we identify the basic operation and their associated cost. Table below lists various operations and cost. Here the term cost refers to the time consumed in executing an operation. The first statement, the first line of the pseudocode, your cost is cost of accessing a of 1, cost of storing a of 1 into max. So the next line, cost of storing 2 into j, cost of comparing index j with n and branching, cost of incrementing j. The third line, if a of j greater than max, the remarks are cost of accessing a of j, cost of comparing a of j with max and branching. The fourth line, then max is assigned with the value of aj, cost of accessing a of j, cost of storing a of j into max element, then return max statement. So cost of returning maximum element. So this is the table of cost of basic operations. So next, count of basic operations. Next we count the number of the basic operations and total cost of executing each statement. The frequency of execution of statement 4 depends on the outcome of statement 3. It will be executed only when the condition a of j greater than max turns out to be true. This condition in turn depends on the order of data in the array A. For the purpose of analysis, we assume that statement 4 is executed k times, where 0 less than or equal to k less than or equal to n minus 1. The table denotes the table of frequency and total cost of basic operations. So next, running time calculation classification. The running time can be best, worst, and average cases. The running time t of n of the algorithm for binding the maximum element of array of size n is given by t of n is equal to a plus b into k plus c into n, where 0 less than or equal to k less than or equal to n minus 1. Here k is the number of times the statement max is assigned with a of j will be executed. The following possibilities can arise. The best case occur when the statement is not executed at all. This happens when the array maximum element occurs in the first cell. So t of best of n is equal to a plus c into n. The next case is average case. In this case, the statement is executed on an average n by 2 times, so that k is equal to n by 2. Thus average running time is given by T of average of n is equal to a plus b by 2 plus c into n. Then next one, the worst case. In this case, the statement is executed n minus 1 times, so k is equal to n minus 1. This happens when this array is sorted in ascending order. Thus worst of maximum running time is given by T of worst of n is equal to a minus b plus c into n. Thank you.